This is lesson 2.2. Okay, prime and composite numbers. Okay, prime and composite numbers. Trying to make that an E. Prime and composite numbers. This is something new. If you are not taking notes, I am going to be very sad. It is not optional to watch. You have to take notes. If you do not take notes when we come back, it is a card flip automatically. Okay, I don't handle people taking notes lightly because it's important. Okay, so we need to look at two different types of numbers. And the first one we're going to look at is, I'm going to zoom in a little bit so I can write a little bit better. Prime numbers. Okay, and prime numbers are numbers that only have factors of 1 and itself. Okay, so for example, when I am looking at numbers, we have been finding the factors of so many different numbers. Okay, some numbers have lots of different factors or lots of different combinations. Some of them only have one group of combinations. So for example, if I were to find the factors of 3. Okay, so for example, how do I want to make this? Let me just give you a bunch of examples of 3. So here is 3, right? Factors of 3 are only 1 times 3. That's my only combination. Okay, factors of this number, which is the number 3, are 1 and 3 in my list. Okay, we call these numbers that only can multiply by 1 in itself. That's the only combination. So if you do this, we've been using, let's use purple. If 1 and 3 is your only combination, so the number 1 and then the number that you are finding the factors for, we call this prime. So 3 is prime. Okay, it's a prime number. If it's only 1 in itself, when you make that list, if you only get the number 1 in itself, and it's the only one, it is called a prime number. Let's look at the number. Let's look at the number 13. Actually, let me put it over to the side a little bit more so we have some room. The number 13. I can multiply 1 times 13 to get 13. Can I multiply 2 times something to get 13? Can I multiply 2 times something to get 13? No. Okay. What about 3 times something? Does 3 times something give me 13? Nope. Does 4 times something give me 13? Nope. What about 5? Write down 5. I'm going down those lists. 5. 5 times something give me 13? Nope. What about 6? Okay, so I'm kind of running out of a list of things, right? If I haven't doubled already, I probably won't. So let me highlight this in purple, or you can square it off with your pencil. Whoops, how do I go back? Okay, that's what I wanted. Get my pencil back. Square that off with purple. Okay, so then I know factors of 13 are only 1 in 13, the number 1 in itself. So I know that 13 is called a prime number. Here are 2 examples for you. So we had 3 and we had 13. 3 and 13 are both prime numbers. When I factor them out, when I make my list of combinations, it is only 1 in itself. If you think this is super simple, go ahead and give me a thumbs up. Yes, I got this. I was telling the 3rd grade teachers that you guys were rocking out finding factors. They were very impressed. Okay. Now, if we have prime numbers, we have something that is the opposite of a prime number. So we call this a composite number. I'm going to circle it. So we have prime numbers and composite numbers. Composite numbers are numbers that have many factors. And usually it is, instead of many, I could have put 3 or more. Okay, so we'll put 3 or, wish I could write that smaller, 3 or more. Okay, because if we have 2 factors, it's technically prime. So 3 or more. Okay, I'll give you a second to write that down, and then we'll do some examples, and then I will show you your assignment. We are looking good. I love everyone's video is on. I'm missing one friend here. Let's see here. There we go. Okay. And we are all taking notes, it looks like. Very nice. Okay, so we learned prime numbers are numbers that only have the one factor in itself. Composites have many factors. So in the chat, can someone give me a number that has a big list of factors? Someone give me a number that has a big list. Ooh, that's a big number. I'm going to go with this one. I'm going to go with the number 20. Okay, 20. Should have wrote that a little smaller so it can stay on the line. 20. I want to save my paper here. So I can do 1 times 20 to give me 20. Can I do 2 times something to give me 20? Can I do 2 times something to give me 20? Yes. 2 times 10 gives me 20. What about 3 times something? Will 3 times something give me 20? Will 3 times something give me 20? No. What about 4? Will 4 times something give me 20? Yes. 4 times 5 gives me 20. Good. Okay, let me square off my list here. We've been using green for one that has multiples, I believe. Okay, so if I said factors of 20 are 1 in order with a comma, 1, 2, 4, 5, 10, 20. Wow, that's a lot. If it has a lot, just like this, has more than 3, we call that composite. So 20 is composite. Let's do the number 4. By yourself, I will give you 1 minute because it is very short. Figure out if the number 4 is prime or composite. Is the number 4 prime or composite? And if it's one or the other, I need you to tell me what the factors are. So I will give you a minute for us to go over it. Okay, go ahead and take a minute, see if 4 is prime or composite. And then you can check your answer in a minute when I go over it. Go ahead and do that now. Figure out if the number 4 is prime or composite. All right, on your paper, you should have had 1 times 4 equals 4. You should have wrote that out. You should have also wrote out 2 times 2 because that is a number combination. I know then the factors of 4 are 1, 2, and 4. If I have a combination of more than 2, so here we have 3. Any number that has 3 factors, 1, 2, 3, or more, is a composite number. If you got composite, go ahead and give yourself a pat on the back. Nice job. Okay. Very nice job. Okay, I will leave this here.